All right. Hi, everybody. My name is Anish. I'm the CEO and co-founder of Komodo AI. So I actually came here a few months ago and presented what we were working at Komodo, and a lot has changed in that time. But before I tell you about kind of the exciting changes we made, I want to give you a little bit of background on how we started with the platform. So Komodo originally was a GPU cloud and developer platform all in one. Users could easily spin up GPU-backed notebooks, launch serverless training jobs, and serve their own fine-tuned models, and we will automatically handle all of the scaling and load balancing around it. And all of this was provided through a very simple interface that wouldn't require any code changes at all. Now, as we were building this and onboarding users, we noticed something. We noticed that by far, the most popular feature we had was our model serving vertical. And people would tell us that the other two verticals about GPU notebooks and serverless training jobs, they were already using platforms like BrevDev, RunPod, AWS SageMaker, and they didn't see a compelling enough reason to switch to our platform. But when it came down to model serving with our unique interface, people really loved it. We had really strong feedback, and all of our feature requests were all related to model serving. People wanted more out of this platform. And so we decided to do the classic startup move. We're pivoting. Our new mission is to build the best inferencing platform on the market. So we're building this because we have seen that more and more AI companies are fine-tuning their own models. And they're doing this because, one, they have so much traffic that it actually makes more financial sense to self-host, or two, they can get much better performance on their unique use case with a fine-tuned model versus a more general model like ChatGPT. But the problem here is that serving fine-tuned models is hard. If you want to have really fast response times, you need to have dedicated compute for it, which means that you are paying for GPUs 24/7. And GPUs are really expensive. H100s can be like $3 an hour. In addition, as you scale this, the cold start problem becomes really apparent, where starting a model on a new GPU instance can take over a minute. And so that means the first person to use your LLM on your app, if there's been several, like a long period of downtime, they're gonna have to wait over a minute just to be able to talk to the model. On top of that, there are also many possible choices for inferencing engines and hardware. And so companies have to do their own research to figure out what works well for them. Now, the solution today to this is serverless GPU platforms. For these platforms, you only pay for the compute you need, and those platforms will handle all the auto scaling around it, so that you can scale really quickly and you don't need to deal with the GPU infrastructure at all. And so platforms like Modal Labs, RunPod, and Base10 do serverless GPUs really well. Their approach is simple. You basically just bring your own inferencing code where you will run, let's say, VLM. You'll upload your model, and the platform will handle all the infrastructure. And this is sort of how we were doing it with Komodo as well, where people would just bring their own inferencing code, and we will handle the deployment and scaling of it. And so in the case of Modal and Base10, they provided a very simple Python API where you just provide your inferencing code and they will wrap it for you. But the problem here is that cold starts and model performance are still a huge bottleneck. The platforms like Modal and Base10 have reduced the container start times down to less than a second, which is amazing. But once your container started, that's where your code comes in. And now your code has to load the inferencing engine like VLM. The model has to be loaded into memory. And so this process can take even over a minute before your model is actually ready to be used. So the part of the stack that's optimized to start this container is not enough. There needs to be better optimizations to reduce that time to your first token. In addition, what we found is that our users had this problem, and even users of all these platforms had this problem as well. But we found that they're all pretty much doing the exact same thing. Anyone who's fine-tuning models is using, usually it's like Llama 3 or 5-Vision Instruct, and they're using VLM or TensorRT and Triton. But a lot of these people aren't actually doing enough of the research to figure out the exact optimization parameters around using all these engines to squeeze out the best performance possible. And so we think that these cold starts can be reduced significantly with the right optimizations. And so our approach is to own the entire inferencing stack, from the Docker image to the inferencing engine that will be used, all the way down to how we actually load models into memory. And so for the specific model architectures like llama that we'll support, we will find all of the right optimizations for how to load this model and run it as quickly as possible. So for a specific model, we'll find out if it's right to use VLM or if we should quantize it with TensorRT and deploy it with Triton Inference Server. And so the way we're going to start is we are starting with small models up to 8 billion parameters. And we're creating a serverless platform on fractional GPUs, specifically A100s and H100s. That way, you can run your model on a GPU as powerful as an H100, but at a fraction of the cost. And so rather than bringing your own inferencing engine and your own inferencing code, you will just upload your weights and we will handle everything else. And then right from the dashboard, you'll be able to interact and chat with your model. So to show you why we're starting with this, I have two machines available here. So on this machine, you can see I'm running an A10 GPU and I have Llama 3.1 running on it right now. You can see it uses pretty much the entire GPU, about 20 gigabytes. And then I have another machine running here. This is an H100, and I'm only using a quarter of this H100. So if I wanted to send a request to my model and see how long it takes on an A10 GPU, so I'm going to run, okay, I'll run that one. And then on here, I'll run the exact same thing. And so on the case of the A10, it took 5.2 seconds. And on the case of a quarter of an H100, took 1.5 seconds. And so you can get much better performance on a fraction of an H100 and pay even less than you would with a cheap GPU like an A10. In this case, I'm paying about 15% less for that fraction of an H100 versus an A10. And so the idea that we're doing is that we will provide you with the different deployment options depending on how you want to optimize cost versus performance of your model. You will basically just upload your model weights, and we will provide a simple HTTPS endpoint that you can integrate into your product. You can chat with a model right from the dashboard, and we'll handle all the infrastructure for you. And so the kind of vision with this is to be able to support all of the major generative model architecture. So we're starting with the most common ones that we've seen. So we're starting with Llama 3. And as we get more requests for new model architectures, we will manually support those architectures, find the right optimizations to have this be the best possible way to deploy that model architecture. And on top of that, we actually want to build a whole platform around the model that you've served so that rather than just being able to serve it, you can actually interact with your model, you can chat with it, you can benchmark its throughput, its tokens per second, and even see how users are using the model, find edge cases, find all the common use cases, and iterate off of that. We also want to leverage different types of hardware like AMD and even specialized inferencing chips that we see a lot of startups building right now, like Volantis ML. And we have actually already partnered with 2 AMD providers and 3 NVIDIA providers to help us build out this platform. And so for a given model architecture, let's say you wanted to deploy your own fine-tuned Llama 3.1, we will actually provide you with the different options of we could run it with VLM on this hardware or Triton and TensorRT on this hardware, and we'll give you the price and the performance that you can expect from that deployment option. And so we will handle all of that optimization research for you. You just pick the deployment option that works for you. And so if this is a vision that excites you, please sign up on our waitlist. I'd love to hear about your inferencing needs, what model architectures you want to support. And by working with us at this early stage, you can help shape the type of optimizations we're going to make. And you can even request a model architecture and we will hand optimize it for you and get it deployed in a completely serverless fashion. Thank you.
Questions?
Yeah. So really nice work. I was wondering, how do you guarantee security of your model? So if I'm sharing a GPU with others, can others read my model, like read my weight?
No. So we, first of all, even to you as the user, like we're not exposing these machines at all. We are just providing you with that HTTPS endpoint. And so in the terms of like sharing the GPUs, we are completely we're actually fractioning them in this demo. I didn't quite do it because we haven't fully built it out yet, but we are fractioning these GPUs using NVIDIA's MIG software. And so each container that we run on that machine will be completely isolated. Like the fractions will be completely isolated from each other. Over here.
This fractional idea, will it only work for models smaller than one GPU's bandwidth, or for bigger as well?
Yeah, so the fractional GPUs is specifically for smaller models. So that's why to start with, we're focusing on models that go up to 8 billion parameters, because those are the models that work well on fractional GPUs. Models past a certain size just won't fit on fractional GPUs. But we're specifically starting with this because we see a huge room for really insane cost performance. And also what we've seen with all the users that have used our platform as it is today, that people could actually get a lot better model performance in terms of like accuracy on their own use case on a fine-tuned 8 billion parameter model versus a base 70 bill plus model, because it's been fine-tuned for their specific use case. So there's already a lot of use cases just for smaller models. And we see with like the latest llama models that have come out of Meta that there's a lot more research being put into smaller models for this particular reason. So that's why we're starting with this.
Thanks.
Anyone else? So a fractional model is reside in the GPU memory all the time. I have to offload to a flash memory storage array, go back every time you initialize it.
Yeah, so making a few optimizations around that. For like really popular models that we know get swapped in often, we're going to keep them in CPU memory and then load them onto GPU when the user actually gets a request to that model. We're also actually exploring changes to like VLM to make loading from disk even faster. Notably, and actually Run AI is an example of a company that just open sourced some software around this that we're actually working with right now. One weird way that models get loaded into memory right now is that the entire model from disk gets loaded to CPU and then the model gets loaded to GPU. But you could actually do this so that it gets streamed through the CPU to the GPU, so that even when the full model hasn't been loaded into CPU, the part of the model that has been loaded can be streamed to the GPU while it waits for the rest of the model to be loaded into CPU. And so those are the types of optimizations we're making as well.
Thank you. Okay.
Cool. Thank you.
Thank you, Anish.